Hello and welcome to Brain Bites. Today's topic is directly connected to your health, lifestyle, and everyday choices. We're exploring the true, absolutely fascinating origins of the numbers you use every single day. You know, you might not realize it, but every time you check your heart rate, calculate your monthly budget, or even just set an alarm on your phone, you are relying on an ancient, multi-centurial leap of human genius.
Okay, let's dive right into this. Just imagine, for a second, trying to do modern science, code a piece of software, or even just run a basic corner store using those clunky additive Roman numerals you see on the left. Can you imagine trying to actually multiply those letters? Now compare that to the sleek, incredibly efficient positional system on the right. This cognitive shift from concrete, tally-based counting to abstract symbolic logic is arguably the single greatest mathematical breakthrough in human history.
In this explainer, we're going to look at the Arabic numeral myth, ancient India's cosmic math, the Brahmi visual ancestors, the absolute power of zero, and finally, transmission versus invention.
All right, kicking things off with Section 1, the Arabic numeral myth.
So a lot of us grew up calling our digits Arabic numerals, right? We mistakenly believed the core system was invented in the Middle East. But here's the catch. The medieval Islamic scholars who brilliantly popularized these numbers explicitly credited Indian mathematicians for designing the underlying logical infrastructure. They didn't claim it. They actually called the system al-Hisab al-Hindi, which literally translates to Indian arithmetic.
Moving along to Section 2, Ancient India's Cosmic Math.
To find their real source, we actually have to travel way back to the Vedic period, somewhere between 1500 and 500 BCE. The Indian subcontinent is the true cradle of modern calculation. Unlike the Mediterranean world, where math was often just tied to immediate practical earthly measurements, the ancient Indian cultural fascination with the cosmos necessitated an entirely new way to quantify reality. They needed a system that could handle astronomical precision long before anyone else.
To put this into perspective, ancient Vedic scholars were manipulating massive, mind-bending cosmic magnitudes, and they actually assigned specific names to them. For instance, they used the term parartha for a trillion. Just think about that. This proves they were totally comfortable with the abstract concept of decimal expansion and immense scale, long before Western civilizations even had a practical use for numbers this incredibly large. By the 5th century, Indian polymaths, like the brilliant astronomer Aryabhata, had already built these highly abstract positional frameworks. He didn't just use standard numbers, he actually used Sanskrit syllables to calculate massive cosmic cycles. Consonants acted as digits, and vowels acted as powers of 10. This allowed him to literally encode incredibly complex astronomical constants into easily memorized poetic verse. Talk about a massive conceptual leap.
Okay, Section 3, Brahmi, the visual ancestors.
Now, while all this conceptual math was expanding in the minds of scholars, the physical shapes of the numbers were actually evolving on rock edicts and cave inscriptions across the subcontinent. As you can see here, the direct graphic ancestors of our modern digits began way back in the 3rd century BCE as simple Brahmi strokes. The numbers 1, 2, and 3 literally started as horizontal lines. Over centuries, these evolved into the distinct cursive glyphs that form the visual backbone of what we write today. But you know, the true genius wasn't just in drawing new shapes. It was the massive cognitive shift. Early systems were concrete and additive. Basically, you needed a totally new symbol for 10, another one for 20, another for 100. Indian mathematicians shifted this to a pure, abstract, positional base 10 system. Suddenly, with just a handful of symbols, you could write literally any number in the universe just by changing its position. Which brings us to Section 4, the power of zero. To make a pure positional system work seamlessly, Indian mathematicians had to invent something absolutely revolutionary. Other cultures had placeholders, sure. Actually, scratch that, they were just empty spaces. But dating back to the 3rd or 4th century Bakshali manuscript, ancient Indians used a dot to represent shunya, or the void. This marked the very first time in human history that zero was treated not just as an empty spot on an abacus, but as a real, functional mathematical digit. So the crucial turning point hits in 628 CE. Working out of the Great Astronomical Observatory at Ujjayan, the mathematician Brahmagupta formally laid down the arithmetic rules for zero and negative numbers in his text. He declared that the sum of two zeros is zero, and a negative times a negative is positive.
By giving nothingness actual, rigorous mathematical laws, he completely transformed abstract symbolic logic. If you're finding this video useful so far, take a second to like the video. It really helps the channel grow and reach more people. Let's think about a what-if scenario again. Contrast the exhausting, totally error-prone process of multiplying Roman numerals, which required this crazy complex method of halving and doubling, with the blazing efficiency of the Indian positional grid system. Without this exact Indian innovation, modern commerce, engineering, or sending a rocket to space would be practically impossible. Our entire global scientific revolution depended on this.
All right, our final segment, Section 5, Transmission, not Invention.
So, how did this brilliant logical infrastructure eventually make its way to the keyboard you're using right now? Well, it took an incredible multi-centurial journey. It started with the Indian subcontinent's conceptual breakthroughs, diffused through the Islamic Golden Age in Baghdad, and finally tracked its way into Renaissance Europe. Now, long before Europe even touched these numbers, scholars in the Middle East explicitly recognized and totally marveled at the superiority of this purely Indian creation. In 662 CE, a Syrian bishop named Severus Sebokht wrote about this ingenious method of calculation, completely aware that this profound mathematical leap came directly from the Indian subcontinent. The huge leap westward happened in the 9th century. A Persian polymath named Al-Khwarizmi wrote a famous textbook systematically codifying Indian arithmetic for the Islamic world. His work was so phenomenally influential that the Latin translation of his very name gave the Western world the word algorithm. That is a real game changer right there. From the Middle East, the system slowly trickled into Europe. Champions like Pope Sylvester II, and later the Italian mathematician Fibonacci in his 1202 book heavily promoted the method of the Indians. And despite intense resistance from traditionalists who clung to Roman numerals, the sheer commercial and scientific efficiency of the Indian system meant it eventually took over all of Europe by the 15th century. Today, these 10 simple symbols are a universal, multicultural legacy. But, as we've explored in this explainer, their core logical infrastructure, that pure positional place value, and the revolutionary functional zero, will always remain deeply rooted in the profound cosmic wonder and abstract brilliance of the ancient Indian subcontinent. Take a second to really think about this. How different would our world be without the invention of zero? How drastically hindered would modern science, computing, and everyday life be if we were still trying to calculate the universe using Roman numerals? The Indian numeral system is quite literally the invisible engine powering everything around you. If you enjoyed this video, hit the like button, share it with others, and subscribe to Brain Bites for more valuable insights. Keep wondering, keep learning, and we'll catch you next time.